right, last lesson of chapter 5. Today we're going to be proving lines parallel. So previously we learned a whole bunch of rules about angle relationships when lines are already parallel. So we are going to be using the postulates and theorems from lesson 3-2. So I'm going to put that up here. Postulates and theorems from the 3-2 notes. You should have this written down somewhere because it was there were the notes that you wrote down. It was an assignment like 2 weeks ago where you had to, on the left hand side it was all the postulates, and on the right hand side it was the converse postulates, and you guys had to write those down and submit them for a grade. It was along with the angle relationships thing. So that's what we're talking about today. Specifically, we are focused on the converse postulates and theorems. And I'll get to that in just a second. So our essential question is, how do we prove that two lines are parallel? How do we prove two lines parallel? How do we prove two lines are parallel? So again, before we were saying, okay, if I have two parallel lines and they're cut by a transversal, then any of the alternate exterior angles are congruent or something like that, right? And then the converse rules just flip-flop that, and they said, okay, if you have two lines that are cut by a transversal and the alternate exterior angles are congruent, then that means those two lines must be parallel. That was what the converse rule said. The original postulates and theorems that was on the left-hand side of that paper you filled out from 3-2 said the rules. When lines are parallel, it stated rules about angles either being congruent or supplementary. The converse was, if the angles are congruent or supplementary, then that proves the lines are parallel. That's what we're using today to prove lines parallel, okay? So these are all from the 3-2 notes. I'm going to go through it with you, and hopefully this will help kind of jog your memory to do your assignment. All right, so the parallel postulate. If given a line and a point not on the line, then there exists exactly one line through the point that's parallel to the given line. All this is saying here, it was kind of a cruddy job of drawing it. They took a line, any line, and they stuck a point up above the line. Anywhere, doesn't matter where it is. And all they're saying is that through this point up here, you can draw a line parallel to this line that the point is not on. So I could draw a parallel line, right? That was like a really crappy example, but this dotted line going through this point here, this point is not on this line, but I can draw a line through the dot that's parallel to this line. That's all they're showing here. Okay, we're not going to use that a whole lot today. That's what a parallel line is. Okay, example 1. Given the following information, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. Pretty much for everything on today's lesson, we're using the converse rules. Because again, the regular rules from 3-2 said if two lines are parallel, then the angles must be whatever, congruent or supplementary. Today, the converse rule says, okay, if the angles are congruent or supplementary, that means that the lines creating them are parallel. Okay, so, and this is talking about when two lines are intersected by a transversal. So for A, angles 1 and 3 are congruent. Here is our picture. We've got 3 lines here, A, B, and C, and they're all cut by a transversal. It means they're intersected by line D. Line D is running through lines A, B, and C. Okay, so if angles 1 and 3 are congruent, does that prove that any of my lines are parallel? Well, angle 1 is in the same position of this intersection between D and A that angle 3 is in this intersection between B and D, right? So these are corresponding angles. These are corresponding angles. So if angle 1 is the same size as angle 3, if the corresponding angles are congruent, then we know the lines creating them must be parallel. That's the converse corresponding angles postulate. The corresponding angles postulate said that if two lines are parallel, cut by a transversal, corresponding angles that are created by using this transversal are congruent. So then backtracking, if we already know these two angles are congruent and they're corresponding, then we know the lines that created them must be parallel. So this is the converse corresponding angles postulate. So we can say, yes, that line A is parallel to line B. And the rule that we used was the converse corresponding angles postulate. I'm gonna pause here. I'm gonna you won't see the pause, but I'm gonna try and see if I can find that rule sheet so I can just flip back and forth because I'm feeling like probably a few of you guys are confused at this point. Okay, I'm back. Sorry. We have this guy, right? Remember this? Everyone should have it, whether you kept it or not, I don't know, but you were supposed to write it down and take a picture of it. Okay, so on the left-hand side here, we had our postulates, right? And so these said, like for example, we had corresponding angles postulate. When two parallel lines are cut by a transversal, the corresponding angles are congruent. So we got our two parallel lines cut by a transversal, corresponding angles are congruent. The converse said that if we have two lines cut by a transversal and we know the angles are congruent, then we know that these two lines must be parallel. So this side says we know the lines are parallel, so the angles must be congruent. The converse says we know the angles are congruent, so that means the lines must be parallel. So the converse, they're what we're using for everything today. They're just like the other, whatever the relationship says, right? Alternate exterior angles, alternate interior angles. They're all congruent, right? When lines are parallel, they're congruent. So if you're looking at a picture and you don't know if the lines are parallel, but the alternate exterior or the alternate interior angles are congruent, that tells you that the lines must be parallel then. There's a relationship there. Parallel lines mean congruent alternate angles, right? Congruent alternate angles means you must have parallel lines. So that's what we're using today, the converse side. The side where we know the angles are parallel or supplementary. So that tells us that the lines must be parallel to get that. All right, so here, angles 1 and 3 again. Corresponding angles, that tells us A and B, lines A and B, must be parallel because of the converse corresponding angles postulate. All right, B, angle 1 and angle 4. Angle 1 is 103, angle 4 is 100. Here's angle 1, it says it's 103. Angle 4, it says is 100. What's the relationship between these guys? Well, if we ignore line B, if we pretend that that line B is not even there, angle 1 and angle 4 are alternate interior angles between A and C, right? They're cut by transversal D. 1 is on the inside on the right side of D. 4 is on the inside on the left side of D. They're alternate interior. So they have to be congruent for these lines to be parallel. Are they congruent if 1 is 103 and 4 is 100? No, they're not congruent. So lines, what, A and C are not congruent, sorry, parallel. The lines are not parallel because 100 is not congruent to 103, the measures of our angles, by and that what would have told us that A and C are parallel would have been the converse alternate interior angle theorem. If the alternate interior angles are congruent, that means our lines are parallel. In this case, they weren't congruent, so that tells us the lines are not parallel, but it's the converse alternate interior angle theorem. Converse alternate interior angle theorem. Okay, so again, don't get too confused on this. Figure out what your angle relationship is. Here, 1 and 4 are alternate interior angles. Right? They're alternate interior, right? So to figure out, okay, is this the regular rule or is this the converse rule? Well, ask yourself, do we know the lines are parallel? Or are we trying to figure out if the lines are parallel? If we know they're parallel, this is the regular rule. If we're trying to figure out whether they're parallel, this is the converse rule. And that's what we were trying to do. All right, example 2. find the measure of ZYN so that PQ and MN are parallel and show your work. So I already kind of drew on this a little bit. So I have to find the measure of ZYN, this angle down here. I already know it's 7x plus 35, but I got to solve for x, plug it back in, to prove that this top line is parallel to this line, right? Well, if these lines are parallel, these two angles here, this is what I'm trying to find, it's alternate exterior to this angle, right? So when lines are parallel, alternate exterior angles are congruent by the converse alternate exterior angle theorem. If lines are if angles are congruent, alternate exterior, that means my lines are parallel. So all I'm going to do is set these equal to each other because they're supposed to be the same measure if they're congruent. Solve for x and plug it back in. And then it doesn't say to tell what postulate or whatever I use, but I am using the converse alternate exterior angle theorem. I'm making my angles congruent, which therefore proves that my lines are parallel. So by the converse alternate exterior angles theorem. And then I show my work. So 11x minus 25 is equal to 7x plus 35. Because again, they're alternate exterior angles, so they have to be congruent if my lines are parallel. Okay, and then I solve for x, so minus 7x, 4x minus 25 equals 35, add 25, 4x equals 60, divide by 4, x equals 15. But it didn't tell me to solve for x, it told me to solve for the measure of this angle down here, ZYN. So the measure of angle ZYN equals 7x plus 35, and we know x is 15. 7 times 15, 7 times 10 is 70, 7 times 5 is 35, 70 and 35 is 105. And we still have to add this 35, which gives us 140 degrees. Okay, alternate exterior angles when our lines are parallel are congruent. Next one, construction. This one I actually hate. I always skip this example. I don't even like it. It's hard to measure anything on this picture. I know you don't have these in front of you, but we're gonna skip that. All right, example 3. Sumi and Daniela are determining which lines are parallel in the figure. Sumi says that since angles 1 and 2 are congruent, here's 1 and 2, that since 1 and 2 are congruent, that WY must be parallel to XZ. Daniela disagrees and says that since 1 and 2 are congruent, WX must be parallel to YZ. So who's correct? Based on the fact that these are congruent, right? These are alternate interior angles. Does it prove that these two lines are parallel or that these two lines are parallel? Well, you just have to ask yourself, first of all, what's our transversal? Mark that up. WZ is our transversal. And so what other lines create angle 1 and angle 2? Does angle 1 have anything to do with WY? No. Angle 1 is the measure from this line right here up to this line right here. Angle 2 is the measure from this line right here down to this line right here. So we could actually even just ignore these two lines and it doesn't change anything, right? So we could actually have just the top line, the bottom line, cut by the transversal, and we would still have angle 1 and angle 2. Right? So this tells us right here that since we don't even need WY or XZ in the picture, that these two lines being congruent alternate interior angles prove that this top line must be parallel to the bottom line. So it proves WX and YZ must be parallel. So who is correct? Daniela is correct. She said WX and YZ are parallel. Daniela is correct. And we know that the two lines are parallel because of the converse alternate interior angle theorem, right? If it first tells us the angles are congruent, and then that leads us to believe that the lines are parallel, when the parallel part comes at the end, that's the converse rule. When they start off with parallel lines, when they say, okay, given that these two lines are parallel, tell me about the angles. That's the regular rule. When they say, well, the angles are congruent, so tell me about the lines if they're parallel, that's the converse rule. So Daniela is correct because of the, by the converse. And these are alternate interior angles. Alternate interior angles theorem. Angle 1 is congruent to angle 2, which tells us that WX along the top must be parallel to YZ along the bottom. WX is parallel to YZ. Everyone good with that? This angle right here has nothing to do with this line right here. This angle here has nothing to do with this line over here. Nothing touches these lines, no angles. However, these two lines create angle 1, and this line and this guy create angle 2. So only ones that are important here are the top and the bottom, which is why I drew it this way. Hopefully that makes sense. All right, second page of notes. Getting close to the end. All right. Which types of angle relationships have to be congruent? First of all, there's the question. I'm going to draw a little picture here, and hopefully this will help. I told y'all before I'm a visual person. So if I have two parallel lines, let's pretend those are perfectly parallel. They're not, but let's pretend. And then they're cut by a transversal. I got to think about all my angle relationships, right? So I create a bunch of angle relationships here. I have corresponding angles. I have vertical angles. I have alternate interior angles, and I have alternate exterior angles. I also have adjacent angles, two angles that together make up a straight line off of one intersected line. And I think that's it. Vertical, adjacent. Adjacent angles make up a linear pair. That's all my angle relationships here. So I'm going to tell which angle relationships have to be congruent to prove lines parallel. Well, if these two lines are parallel, I know corresponding angles have to be congruent. I know that alternate interior angles have to be congruent and alternate exterior angles have to be congruent. All of my alternate angles have to be congruent. Alternate interior, exterior. All of those are congruent, those angle relationships, if my two lines are parallel. Which types of angle relationships have to be supplementary? Well, the same side stuff, right? Same side interior. This angle, these two, right? These and these. Alternate, same side interior have to be supplementary. And same side exterior have to be supplementary. This guy is a different size than this guy. This looks like it's obtuse. This one looks like it's acute. So together, when these two lines are parallel, these add up to 180. So all of our same side angle relationships, same side interior, exterior. Those angle relationships prove my two lines are parallel. What are some angle relationships that don't have anything to do with whether lines are parallel or not? Well, what about vertical angles? If I said these two angles are congruent, does that have anything to do with proving these two lines parallel? No, because both of these vertical angles are on one line. They have nothing to do with this line. So even though vertical angles are congruent, that's a relationship, they do not prove lines parallel. So we'll say vertical angles What else? What other types of relationships? What about a linear pair? Right? Adjacent angles or linear pairs. These two angles are right next to each other, which tells me they're supplementary. They make up a straight line. But does that help me prove that this line is parallel to this line? No, because all of my angles are just on this line. None of them that I'm looking at are on this line. So a linear pair or adjacent angles do not help me prove that lines are parallel. They are angle relationships, but they don't help me prove lines are parallel. The only ones that help me, now you're going to use this right here. Use these little questions. Write them down somewhere. This helps. Which types of angles have to be the same size, corresponding, and the alternates, alternate interior, exterior. Which angle relationships have to be supplementary, have to add up to 180, all the same side stuff, consecutive interior, same side exterior. That's super important. If any of my other angle relationships are these guys, they're still true, but they don't help me prove that lines are parallel. So this is important, this little section up here. Go back and watch it again and write it down if you didn't get that. All right, we're almost done. Example 1, you try. Given the following information, it is possible to prove that any of the lines shown are parallel. Oh, it's supposed to say, is it? Is it possible to prove that any of the lines shown are parallel? Question mark. If so, state the postulate or theorem that justifies the answer. All right, A, angles 2 and 8 are congruent. Here's angle 2, here's angle 8. If they are congruent, what's their relationship? Alternate interior, right? They're between these two lines cut by this transversal and their alternate interior. So if they're congruent, that helps us prove that A and B must be parallel, right? Alternate interior angle theorem says that when two lines are parallel and they're cut by a transversal, the alternate interior angles are congruent. The converse alternate interior angle theorem says that when alternate interior angles are congruent, the lines that create them, the lines are cut by a transversal, must be parallel, right? So yes, these prove that lines A and B are parallel. Line A is parallel to line B. That little shortcut is like two little parallel lines next to each other. And this is because of the converse alternate interior angles theorem. It tells us the alternate interior angles are congruent, so that must mean that the lines are parallel. That's the converse rule. If you know the angle relationships are congruent, then you can figure out the lines are parallel. B, 3 is congruent to 11. Okay, angle 3 is here, and here's 11. I highlighted them in orange. What's their relationship? These are corresponding, right? Here's our transversal. Here's our two lines that are cut by this transversal. So if this angle and this angle, they're corresponding, if they are also congruent, right, it proves our lines parallel. To prove lines parallel, which types of relationships have to be congruent? Corresponding. These are congruent corresponding according to this. So that means these lines that create them must be parallel. Line L and line M. Line L parallel to line M. And that's because of the converse corresponding angles postulate. Corresponding was the only one that was a postulate and not a theorem. I don't know why. But it's listed on your paper. I need to update your theorems thing. We've added a few and I haven't updated it yet. I'll post that this week. Might be tomorrow or Thursday, but I'll post it. Okay, next one. Angles 8 and 13 add up to 180. Here's 8, here's 13. These two are same side interior angles. They are in between L and M, cut by this transversal B. So they're on the same side of this transversal, and they're in between L and M. So if they add up to 180, that means they're supplementary. which means when same side interior angles are supplementary, that means our lines are parallel. So line L and M are parallel. Line L is parallel to line M because of the converse consecutive interior angle theorem. Converse consecutive interior angle theorem. It's converse because it doesn't tell us that the lines are parallel. It tells us the angles are supplementary, and then we have to figure out the lines are parallel. So when the parallel part comes at the end, it's always the converse rule. When it starts off saying, I know I'm repeating myself, I just want it to sink in. When it starts off saying lines are parallel, so therefore the angle relationship is blah, 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 congruent or supplementary, that's the regular rule. When it tells us the lines are parallel. When it wants us to figure out if the lines are parallel, that's the converse rule. Last one, D, 8 and 6 are congruent. Here is 6, here is 8. These are vertical angles. So does them being congruent prove that anything is parallel? No, because vertical angles are created by two intersecting lines. Has nothing to do with a transversal cutting through two parallel lines, right? It just has to do with two intersecting lines. Vertical lines do not prove lines are parallel. Vertical angles, sorry. So no lines parallel with vertical angles. It's still important that they're vertical, but that doesn't help us prove anything's parallel. Example 2, find y so that E and F are parallel and show your work. Excuse me. All right, so it gives us, I already drew on this, so I messed it up a little bit. All it gave us was this little 90-degree angle here and this angle down here, right? So how can I solve for y if all I know is this? Because there's no relationship between these, right? They're not alternate interior or exterior because this angle is inside and this angle is outside, even though they're alternate. They're not same side, they're not corresponding, they're nothing, right? However, if I know this is a straight line and this is 90 degrees, 90 plus what adds up to 180? Another 90-degree angle. If this is 90, this has to be 90. And then these two angles are corresponding. So to prove that line E is parallel to F, these two angles have to be the same size. They have to be congruent. So if I'm going to solve for y, I have to set it equal to 90 degrees. 4y plus 10 equals 90. And then I can solve for y, subtract 10 from both sides, divide both sides by 4, y equals 20. And it doesn't say to give what theorem I used, it just says to show my work, which I did. But the reason I could figure out to set this equals to 90 if these two lines are parallel is because of the converse corresponding angles postulate. If corresponding angles are congruent, then that means my lines are parallel. Converse corresponding angles postulate. Find y so that E and F are parallel. So first I had to solve for y, and if these are equal, then I can show that these two lines are parallel. That's why we did it in the order that we did, and that it was converse corresponding angles postulate. Last one. We're not doing the reflection, so we're almost done. All right, rowing. In order to move in a straight line with maximum efficiency, rowers' oars should be parallel. Refer to the photo at the right. Is it possible to prove that any of the oars are parallel? If so, explain. If not, explain why not. Okay, there's a picture here, but it is really hard to see when it's printed. You can kind of tell, okay, it's a boat. They've got their oars, their rowers, like over on University. You know, I see that lake over there, and I know the rower is supposed to practice in it or something. I don't even know, but I never see them out there. I'm sure they are. When is that? The spring? The summer, I guess. All right, so here it shows us, which is really hard to see. Here's the straight line of the boat, and it draws a line down an oar, a line down an oar. We're trying to figure out if these oars are parallel, and it tells us this angle is 110 and this angle is 80. So I kind of drew it down here. here's our boat, here's our oars, and it tells us this angle is 110, this one's 180, or this one's 80. So what's the relationship between these guys? If these are our parallel lines and this is our transversal, these are same side exterior angles. And anything same side has to be supplementary, right? All of our same side relationships. So same side exterior angles have to add up to 180. Does 110 and 80 add up to 180? No, it does not. It adds up to 190. So I can say, so since 110 plus 80 equals 190, and 190 is not equal to 180, by the converse same side exterior angle theorem, by the converse same side, such a mouthful, exterior angles theorem, I know the oars are not parallel. Because, again, converse same side exterior angles theorem says that if exterior angles are congruent, that means the lines that create them must be parallel. We had to tell whether the oars were parallel or not, and based on the measure of these angles right here, they cannot be parallel. Because for them to be parallel, these two angles had to add up to 180, and they don't. Hopefully that didn't confuse anybody too much. Just go back and read your notes from 3-2. If you have that whole, where did I put it? This whole paper, it's super helpful to have. That's why I had you guys write it down and take a picture to make sure that you had this. Because even when I add these to my quick little cheat sheet with all the theorems and stuff, I'm not going to be able to fit everything on it like this. It's not going to be detailed. It'll just be abbreviated. All right, let me know if you have questions.